In this video, we are going to first learn how to find critical values of a function. So critical values of a function are going to be those values that make the first derivative equal to 0. So the first thing you have to do is take the derivative. So the derivative of 10x squared would give me 20x, minus the derivative of 100x would just be 100, and then of course the derivative of minus 7 is 0. So you will then take your first derivative and you will set it equal to 0 so that you can find your critical values. So I'm going to solve. I'll add 100 to both sides. So that leaves me with 20x is equal to 100, and then divide both sides by 20, so x is equal to 5. So my critical value is 5. Okay, for the second step of this problem, they're going to ask us to use what's called the first derivative test to find local extrema. And so local extrema refer to either what we call maximums or minimums. So anytime a graph is increasing and then it changes to decreasing, that would be considered a maximum value. If a graph is decreasing and then it changes to increasing, that is what is considered a local minima. So if we go back to our first derivative, remember our first derivative was 20x minus 100. The first derivative test is where we do the number line like I showed you before to figure out increasing and decreasing. And so our critical value was 5. We're going to put in test points that are less than 5 and greater than 5. So 0 is probably the easiest thing to plug in, less than 5. If I take 20 times 0 and I subtract 100, then I am left with just negative 100. So what matters is, or what this tells me is that the graph is, the first derivative is negative on that interval, which tells me that the graph is actually decreasing on that interval. So it's going down. Let's get green here. It's going down. Now, if I use a test point that is bigger than 5, so let's say something like 6, and I plug that into my first derivative, 20 times 6 would be 120, minus 100 would leave me with positive 20. And what matters is the fact that the first derivative is positive on that interval. So what that tells me is that the graph is actually increasing on that interval. It is actually going up. So anytime a graph changes from decreasing to increasing, what we say is that you have a local minima. So when they're asking me what is our local maxima, I'm going to say there's not one, so there is no local maxima. And because we found that the graph is going to decrease and then increase around the value x equals 5, then we know there's going to be a local minima when x is 5. So you've got to find the y value that corresponds to that. So if you'll simply plug that x value of 5 back into the original function, so we're looking for the f of 5. So the original function says we'll take 10 times our 5 squared minus 100 times the 5 minus 7. And so 5 squared is 25 times 10 would give me 250, minus 100 times 5 would be 500, minus 7. So if you take 250 minus 500, you get negative 250, and negative 250 minus 7 would leave you with a negative 257. So they do want both the x and y coordinate of the point when you identify it as either a local max or local min. Okay, next question. We have a rational function this time. So again, to find our critical values, we will take a first derivative and we'll set it equal to 0. So with this rational function, we'll take the derivative of the top, which is 18x, multiply it by the bottom, minus the derivative of the bottom, which is just 1, times the top, which is 9x squared minus 16, all divided by the bottom squared. So when I go to simplify this, I have an 18x squared minus a 9x squared. That becomes plus a 16, all divided by x squared. So 18x squared minus 9x squared would leave me with a 9x squared, and that is plus 16, and then divide it by x squared. So when you go to set this derivative equal to 0, you're going to set the top specifically equal to 0 because that's how a fraction is equal to 0. I subtract 16 on both sides, so 9x squared is equal to negative 16. Divide both sides by 9, and you're going to have x squared is a negative number. Well, we know that x squared cannot be a negative number, and even if you tried to square root both sides, you realize you get imaginary numbers, so there are no critical values coming from there. The other place critical values can come from are values that make your denominator undefined, as long as they're part of the original domain. When I look at my first derivative, x equals 0 would make this undefined, but when you look back at the original function, it is not part of the original domain. So in this case, our rational function does not have any critical numbers.